Good day, students. In this clip, we are going to be reviewing the four conic sections, circles, ellipses, hyperbolas, and parabolas in general form. So let's consider the instructions for the first example. We are to express the given conic in standard form, identify it, find the properties, graph, label, and state the definition of the conic in the context of the problem. All right, so for problem 1, we're going to consider the conic given by the equation x squared plus y squared minus 4x minus 6y plus 4 equals 0. Now, can you determine what conic section this general form of a conic represents? You want to look at the number of squares, the sign, and the coefficient of the squares. We have two squares, which means it could be a circle, ellipse, or hyperbola. The sign in between it is a plus, so it means that it could either be a circle or an ellipse. Since the coefficients are the same, that automatically means that this is a circle. Okay? So this is a circle, and this is a general form of the equation of a circle. The instructions are for us to express it in standard form, and then find the properties and graph. To express this in standard form, we just have to complete the square. To go about that, we'll separate the variables, collect the x's together, x squared minus 4x plus y squared minus 6y, subtract 4 from both sides, equals -4. Now we're going to split our variables into two worlds, the x world and the y world. Now, for the x world, we have an incomplete square, and here we also have an incomplete square. So we want to create a perfect square trinomial in the x world and also in the y world. So we have x squared minus 4x plus a term that makes this a perfect square trinomial. And in the x world, we have y squared minus 6y plus a term that makes this a perfect square trinomial. Okay, equals -4. Now to compensate for what we added on the left side and preserve equality, we have to add that term we added to the x world and add that term we added to the y world on the right side of the equation. Okay. Now, what are the terms that we are going to add, or how do we complete the square? We just simply use b of x and b of y. b of x is -4. How do we complete the square? We divide it by 2, which is -2, and then we square that. That equals 4. So adding 4 makes this a perfect square trinomial. So we have to add a 4 here. And then for the y world, b of y is -6. Divide that by 2. We have -3. You square that, and we get 9. Okay, so adding 9 here makes this a perfect square trinomial. Insert the 9 here also. Okay. Now let's go ahead and factor this. Since this equation, this expression is a perfect square trinomial, I can simply factor it by rooting the first term and the last term and bringing down the middle sign. Okay, so here we have x minus 2 quantity squared. For the x world, bring down the plus. Same story with the y world. You root the first and the last term and bring down the middle sign. Okay, so you're going to have y minus 3 quantity squared. And then -4 plus 4 plus 9 is equal to 9. And this is the standard form of the equation of the circle. Standard form. Okay, this is general form. All right. Now let's go ahead and find the properties. Okay, properties. First thing we're going to look at is the what kind of conic is this? The conic we determined earlier that is a circle because you have two squares and a plus, and the coefficients are the same. So conic is a circle. And the properties you need for a circle, they're not that much. You just need the radius. Okay, so the radius is simply the square root of this number right here, 9, which is equal to 3. And this means that you're going to go 3 units in all directions. 3 units left, right, up, and down. Okay, and then the next property you need is the center. The center is HK, so the center in this problem is the opposite of the number next to the x, so the x coordinate 2, and the opposite number of the number next to your y is your y coordinate 3. Okay, now that we have the center and radius, we can go ahead and graph our circle. Okay, so let's create our coordinate system. Well, let's see, we're in quadrant 1, since we're going to the right 2 and up 3. So we're going to shift our x-axis, our y-axis to the left a little bit, and our x-axis downward. Okay, so that's our coordinate system, x, y. Let's graph the center first. The center is 2, 3, so we go over 1, 2, and up 1, 2, 3. And then we're going to go 3 units north, south, east, west. 1, 2, 3, 1, 2, 3, 1, 2, 3, and then 1, 2, 3. Okay, and then we can go ahead and draw a circle like that, and that's it. Okay, so now let's label. The instructions were for us to label our circle. So this is our radius, and the length is 3 units long, and then that right there is our center. That's the center, and the coordinates of our center is 2, 3. All right, now we have the graph completely labeled. Now let's state the meaning of our result in the context of the problem. So let's write that down. What's the definition of a circle using the problem? The locus of points, the locus or collection of points, 3 units from the fixed point. Fixed point is going to be the center. Okay, from the fixed point 2, 3 is the circle with the equation or equations, with the equations, the first one we can write, let's write it in general form, x squared plus x squared plus y squared minus 4x minus 6y plus 4 equals 0, or the standard form, x minus 2 squared plus y minus 3 squared equals 9. Okay, so that's that. All right, let's take a look at question number 2. We just finished part number 1 on ellipses. On circles. Now we're going to look at another example. So how about if we had the equation in general form given by 16x squared plus 9y squared minus 32x plus 54y minus 47 equals 0. Now we're following the same instructions that we used for part 1. Let's see if we can identify what kind of conic this is. We notice that we have 2 variables being squared here, so that means it's either a circle, ellipse, or hyperbola. We notice that there's a plus between the squared variables, so it's either a circle or an ellipse. The squared variables have different coefficients, so that automatically tells us it is an ellipse. Okay, so this is a general form of an ellipse. All right, now our task, first of all, is to convert it to standard form so that we can find the properties with ease. Now let's organize our variables. 16x squared minus 32x. The x's together, plus 9y squared plus 54y. The y's together, and then you subtract 47 from both sides. Okay, what we're going to proceed to do now is split our variables into their respective worlds, the x world and the y world. Okay, now let's see here. When we are completing the square, we want to make sure that the squared variables do not have a coefficient. So our goal, first of all, to create 2 perfect square trinomials. is to factor out the coefficient of the squared variable from the two terms in their world. Okay, so I'm going to factor out 16 from these two terms. So I'm going to have 16 times x squared. If you factor out 16 from negative 32, you'll be left with negative 2x. And then we're going to add a term that completes the square in the x world. Okay? Plus, the same story here, to have a to put this in a form that's easy to complete the square, we have to factor out the coefficient of the y squared, which is 9. So we factor out 9 from these two quantities in the y world. We'll have y squared plus 54. I'm sorry. If we factor out 9 from 54, we'll have 6 plus 6y. And then we're going to add a term that completes the square in the y world. Okay, so plus that term that completes the square equals 47. Now what are we going to add on the right side to make sure that we have a balanced equation? Well, before we do that, let's find out the terms that I'm going to insert here first. Okay, so in the x world, let's see, v of x is negative 2. So to make this a perfect square trinomial, we'll divide that by 2, negative 1, and you square that, equals 1. Okay, so we add a 1 here. And then in the y world, what we'll do is we'll extract our v of y, which is 6, divided by 2. That yields 3. And when you square 3, you get 9. Okay, so put a 9 here. Okay, so what do we add on the right side to preserve equality on our equation? We're going to add, you don't just add the number, you have to multiply it by the number you factored out. Okay, so we're going to have plus 16 times 1 that I inserted in the parentheses, plus, you have a 9 here, 9 times the 9 in here. Okay, so this is slightly different from the circle case. When we're doing the circle in the previous problem, we didn't have a coefficient outside the parentheses, so this term was sufficient to be added in the right side to preserve equality. But anytime you have a number outside, you must multiply by the number you introduced. All right, so let's simplify this further. We're going to have 16, and then let's factor this using the factoring trick we went over before. You root the first and the last term, and then you bring down the middle sign, and then you'll have x minus 1 quantity squared plus 9. You root the first and the last, and bring down the middle sign, and then you have y plus 3 quantity squared equals 47 plus 16 plus 81 is 144. Now to place our ellipse in standard form, we have to set this equal to 0 and also address these constants in front of the squared quantities. They shouldn't be there. Okay, so let's deal with this side first. We divide the entire equation by 144, 144, 144, and 144. Okay, now let's reduce that. We're going to have 16 goes into itself once and goes into 144 9 times. So that yields x minus 1. Let's try that again. So here 9 times. So we have x minus 1 quantity square over 9 plus, and then 9 goes here 1, 9 goes into 144 16 times. So for the y world, we have y plus 3 quantity square over 16 equals 1. This is excellent because by dividing by 144, we also got rid of the coefficients in front of the parentheses. So now we have the standard form. Okay, now we're ready to find the properties. Let's write that down, properties. Okay, first thing we have to do is identify the conic. We already did that. This conic section that we are dealing with here is an ellipse. Okay, so the conic is an ellipse. Next thing we have to identify is the center. The center is HK. So we have the opposite of this number is 1. Opposite of that, -3. So there goes your center. And the next thing is the direction of axis. Direction of axis. Now, you know that the x-axis goes side to side. That impacts the direction of this number here. And then the y-axis goes up and down, right? Okay, so let's start with the x piece. The square root of 9 is 3. So we're going to go 3 units side to side from the center. Square root of 16 is 4. So we're going to go 4 units up and down from the center. Alright, so we have to identify the major and minor axis. Since the major axis determines the orientation or direction of the C for the foci. The major axis is the bigger of the two. We can clearly see that the y direction is a major. Okay, so this is a major axis direction, and this is the minor axis direction. Alright. Okay, now next thing we need to find is the C of the foci. C of the foci. There are two focus here. C of the foci is the square root of, we have a plus here, so we're going to do the difference in the denominator, 16 minus 4, which is equal to 16 minus 4 is 7, so the square root of 7. And if we plug that in our calculators, that's approximately 2.65. What direction does this go? It goes in the direction of the major axis, up and down. Okay? And then the eccentricity of our ellipse, how stretched it is in the direction of the foci, of the major axis, sorry, is simply C divided by our major axis. Okay? So C is square root of 7, and then we just divide that by 4, and that will give us the length of our, that gives us the eccentricity of our ellipse. So if you plug it in your calculator, this is approximately 0.66. All right, now let's take a look at the graph of our ellipse. So let's see, we're going 1 to the right and 3 units down, so our ellipse will be centered in quadrant number 4. So let's set up our coordinate system, keeping in mind the location of the center. Alright, so I'm shifting my x-axis upwards considerably here because my center is in the 4th quadrant. Okay, so now there goes my x and my y-axis. Let's label it y and x. Alright, now we're going to graph and fully label our ellipse. First thing we're going to graph is the center. 1, -3, 1, 1, 2, 3. There goes the center. We're going to go 4 units up and down. 1, 2, 3, 4 for the major axis. 1, 2, 3, 4. And then 3 units side to side. 1, 2, 3. And then 1, 2, 3. Okay? And then we can draw our ellipse as best as we can. Just connect the dots, kind of like an oval shape. That's not good. Let's try that again. Let's draw this part. Alright, so there goes your ellipse. Now let's go ahead and start labeling our ellipse. So I like to focus my attention on the major axis first because that's where a lot of the action is. Okay, so this line, this segment right here is a major axis because it's the longer of the two. So let's start labeling. We're going to start with the center. Just right there is the center. The center is 1, -3. Next thing we're going to graph are the foci. 2.65 in both directions, so I'm going to go up 1, 2.6, that's somewhere here. Alright, and then 1, 2.6 is somewhere here. Let's label those. This is, we'll call this focus 1, focus 1 coordinates, you just simply add 2.65 to the to the um, to the y-axis, since we're going in the upward direction. So we're going to have 1 comma point 35. I'm sorry, negative. Fix that. 1 comma negative 0.35. All right, and then going down 1, 2, and then 0.65 gives you focus 2. Let's label that focus 2 is going to be 1 comma subtract 2.65. Here you have negative 5.65. Okay. All right, now let's shift our attention to the vertices. The vertices on our major axis are our major vertices. Okay, so let's label this. This is major vertex 1, major vertex 1, and the coordinates are going to be 1 comma 1. Okay, and then this right here is major vertex 2, major vertex 2 is going to be let's see, we're at negative 3, 4, 5, 6, 7. So 1 comma negative 7, major vertex 2. Now next thing we're going to graph is our major axis line. Let's go ahead and graph that. Our major axis line, let's make it red. So our major axis line is this line right here. So let's go ahead and label it. So this is our major axis line. Major axis line, and it has the equation x equals the x coordinate of the center, which is 1. All right, we also have to label our major axis. This right here is our major axis, and also how long it is. Okay, so this is our major axis, and it's well, let me put it on the other side because I'm running out of space. So put it over here. Major axis length is 4 units up and down, total of 8 units. Okay, so that's how long our major axis is. Now let's shift our attention to the minor axis. There isn't too much going on there. We're just gonna label our minor vertices, and that will, and also the length of our minor axis, and that will be that. Okay. So this is minor vertex 1, and the coordinates are let's see, 1, 2, 3, 4, 1, 2, 3, 4 comma negative 3. Or you can simply subtract 3 from your x coordinate of the center, and then that takes you right here. Okay. Now let's shift our attention to the other, to our other vertex, minor vertex 2. So this is minor vertex 2, and the coordinates are starting from 1, negative 3. We're just going to go 1, 2, 3 here. So the coordinates are 1, 2, negative 2, 1, 2, 3, negative 2, comma negative 3. So negative 2, negative 3. Now, last but not the least, let's graph our minor axis line. Okay, the line containing our minor axis. Let's make that blue. So we're going to have the minor axis line, and then we just indicate the equation of our minor axis line, and then we'll be able to move on to stating the depth, the mean. Okay. All right. So there goes our minor axis line. Minor axis line, and the equation is the y coordinate of your center, which is negative 3. So y equals negative 3. So there goes your graph and fully labeled ellipse. Okay, so let's go ahead and state the meaning or the definition of an ellipse in the context of this problem. Go ahead and write it down. So let's have everything in view. So the definition in the context of this problem is as follows. The locus of points whose distance or whose sum of distance whose sum of distance from two fixed points these fixed points are the foci. Okay, so let's label them foci 1, focus 1, fixed points. That of view 1, comma -3, -0.35, and the second focus is 1, comma -5.65. So whose sum of distance from two fixed points is constantly the length of the major axis is constantly 8, is the ellipse with the equation 16x squared plus 9y squared minus 32x plus 54y minus 47 equals 0. Or you can place the standard equation. They mean exactly the same thing, all right? So that's that. All right, let's take a look at question number 3. We're going to be doing exactly the same procedure for problems 1 and 2. We're going to express the given conic in standard form, identify it, find the properties, graph, label, state the definition of the conic and the context of the problem. So what if we have the conic with the equation negative x squared plus 4y squared plus 4x plus 16y plus 8 equals 0. Now what kind of conic section is this? Now if you look at the squared variables, you notice that we have two squared variables. So that means it's either a circle, an ellipse, or a hyperbola. Now since the signs, you have a negative, one of the squares is negative, that automatically makes it a hyperbola, all right? So this is the general form of a hyperbola, general form. Our first task is to convert this into standard form, okay? So let's collect variables together. Now you notice that the x variable is squared, the leading term in the x world is squared, so I'm going to move it back and put the y in front since it's positive. So I have 4y squared plus 16y minus x squared plus 4x. Okay, I have the y's together and then the x's together, and then I'm going to subtract 8, move it to the other side because it belongs to neither the x nor the y world, so minus 8. Alright, now what we're going to do is divide our worlds into two. You have the x and the y worlds. And then we're going to create two perfect square trinomials by completing the square. In order to complete the square in these two expressions in the two worlds, we have to make sure that the squared term has a coefficient of 1. So we notice that this has a coefficient of 4, so that needs to be factored out. So we're going to factor out the 4. And that leaves us with y squared plus, factoring out 4 from 16y, you have 4y, plus the term that completes the square in the y world. Okay. Now let's shift our attention to the x world. We have a minus 1 here, so we have to take care of that negativity. So we'll pull out a minus, so we have negative. You could put a 1 out there if you want, but we don't have to. Negative parenthesis x squared. And if you factor out a minus from a plus, this becomes a minus 4x, plus the term that completes the square in our x world, making it into a perfect square trinomial. Okay? Alright, -8, we're going to add terms here to make sure this is a balanced equation. So before we do that, let's figure out what the terms that makes these two quantities perfect square trinomials. So starting with the x world, b of x is 4. So we're going to divide that by 2, which is 2. And then we square that, that's 4. So we're going to add 4 here to make this a perfect square trinomial. And in the x world, b of, oh snap, this is b of y, hold it b of x, this is b of y. Now what we're going to do is b of x. Okay, so this is b of y. Now b of x is -4. Divide that by 2, you get -2. And when you square that, you have 4. So 4 being added here makes this a perfect square trinomial. So what do we add on the right side of this equation? In order for it to be a balanced equation, we're going to add 4 times this term that we introduced right here, 4 times 4. Now, how did that happen? We added a 4 in this parenthesis, but there was a 4 out here that's been multiplied by the 4 that we introduced. So in essence, we added 16 here. So that's why we have a 4. This 4 is for the 4 out here, the coefficient. And this other 4 is the 4 that we added by completing the square. In the y world, we have imagine there's a -1 here, so it's going to be a minus. This term right here, 4, is the only thing that we introduced there, minus 4. Okay? Alright. Now, let's go ahead and finish this up. So, you might wonder why is this a negative if you multiply plus or minus. That's why we have a minus there. Okay? Now, we're going to factor this perfect square trinomial by using the factoring trick. You root the first term and the last term, and then you bring down the middle sign. Okay? So let's see what that gives us. Just do a 4 on the outside. 4 times y plus 2 quantity square for the y world. Alright? And then we have minus. You root the x square and root the 4. And you bring down the middle sign. And then we're going to have x minus 2 quantity square. Now on the right side of the equation, let's go ahead and simplify this. This is -8 plus 16 minus 4. That gives us +4. Now to get this into standard form, we just have to set it equal to 1. So what we're going to do is divide every single term by 4. Divide this by 4, divide this by 4, and divide that by 4. Alright, so if we reduce that, we're going to get y plus 2 squared over 1 minus x minus 2 squared over 4 equals 1. Okay, so there goes our standard form of the equation of the hyperbola. So let's write it down, standard form. Now, what we're going to do is find the properties. Okay, so let's go ahead and do that. Properties. Okay, we're going to start by identifying what the conic is. We already did that before. What kind of conic is this? This is a hyperbola. Because we have 2 squares, a minus, and the coefficients were different, or the denominators are different. Okay. Next thing we need to find out is the center, HK. Opposite of the number next to the x is +2, and then opposite of the number next to the y, -2. Now you have to be careful. You have to pay close attention to the variables, all right? X's do not always come first when you're orienting conic sections in standard form. So you have to be careful with that. Now we have the center. Next thing we need is the direction of the central box. Okay, let's write that down. direction of central box of central box. Okay, so underneath the y squared quantity we have 1, so we're going to do the square root of 1, which is 1. So we're going to go up and down 1 unit, and then square root of 4, which is 2, is underneath the x, so the central box goes side to side. Now, which of this is the real and which is the imaginary axis? When you're dealing with hyperbolas, the sign is what counts. Whichever one is positive, that's where the transverse or real axis is. Okay? And then the one that has a negative in front, that's the imaginary or conjugate axis. So let's go ahead and label it. The one that's positive is the y. So this is the going up and down, the direction that goes up and down, that's your transverse or real axis. Okay, real axis. All right, and then the one going side to side, that's your conjugate or imaginary axis. Okay, now next thing we need to find is the C of the foci. C of the foci, we have two focus here. C of the foci, we're going to do the square root of, since we have a minus here, we're going to add the denominators, 4 plus 1, which is equal to 5. So we have the square root of 5, which is approximately 2.24. Okay, so it's approximately 2.24. Now, what direction is it going to go? Is it going to go side to side or up and down? Well, it goes in the direction of the transverse or real axis, okay? So it's going to be going up and down from the center. All right, next thing we need to find is the eccentricity of our hyperbola. Eccentricity. So our eccentricity is basically the foci, C of the foci divided by your real axis, okay? So C of the foci is square root of 5, that divided by the real axis, which is 1. So our final answer is basically square root of 5. Square root of 5 or 2.24. So there goes our eccentricity. All right, now let's go ahead and take a look at the graph. Let's go ahead and graph the hyperbola. All right, so the center is 2, -2, so that's located in quadrant number 4. So we have to make our fourth quadrant sufficiently large to compensate for that shift, okay? So shift your x-axis to the left, your y-axis to the left, and shift your x-axis upwards somewhat. So there you go. Now let's graph the center. Center is 2, -2. So this is our x-axis. So y-axis. So 2 and -2 is down here. Next thing we're going to graph is the direction of our central box. We're going to go up and down 1 unit. And then we're going to go side to side, I think 2 units. So there goes your central box. Now let's go ahead. So 1, 2. All right, so there goes your central box. Now let's go ahead and graph the central box. I'm going to use dotted lines here. Let's make this dotted. Okay, perfect. All right, so there goes your central box. This is not part of the graph, so just make it dotted right now. Dotted, 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 like that. Okay. All right, now we have our central box. Next thing we're going to graph are our asymptotes. So to graph your asymptotes, you just basically connect the vertices of your central box like that. I'm going to extend it in a second. All right, right, so when you're sketching your hyperbolic curves, you want to ensure that you approach the asymptotes, okay? And you never want to go into that central box, that restricted area. You have to reside outside it. Have these hyperbolas guide your construction. So what was the orientation? What is the, oh, we also have to indicate the opening of our um, hyperbola. Let's go ahead and indicate what that is. What is the opening? In what direction does a hyperbola open? It opens in the direction of the transverse or real axis. In this case, it's up and down. So opening is up and down. So we're going to have a hyperbola opening upwards and downwards right there. Okay? So let's go ahead and draw our graph. So from here, let's draw it as best as you can. You approach the asymptote, it just goes on like that forever. Okay? And from here, you approach the asymptote, like that. And then you can do this side to the best of your ability. Alright, so there you have it, your two your hyperbolic curves. Okay, now what we're going to do is we're going to proceed to start with to start labeling our hyperbolic curve. Okay, so the first thing we're going to do, I like to start by graphing my my transverse axis, transverse or real axis. This is a transverse or real axis right there. So we're going to graph the center first. So where's the center located? Let's go ahead and label that. So this right here, that's the center. The center has coordinates, center's coordinates 2, -2, 2, -2. And then this is our transverse or real vertex 1. So, well, actually, just the only vertex that we have. So this is vertex 1. Vertex 1. Vertex 1 is going to be 1 unit up. So we are adding 1 to our y-axis. So it's going to be 2, -1. And then this is vertex 2 right here. Now, vertex 2. And that's going to be 2. And then you subtract 1 from the y-coordinate, 2, -3. Next thing we're going to graph are our foci. So our foci is 2.24 units up and down. So 2.24 is going to be somewhere here. That's our first focus. Let's go ahead and label that. This is going to be put it right here. Focus 1. Focus 1. Focus 1 is our x-coordinate is still 2, and our y-coordinate is, you end up 1, 2, and then 0.24, so 0.24. That was our focus 1. Focus 2, we're going to go 2.24 units down from the center, 1, 2.24. So right there, it's an approximation. That goes our focus 2. Focus 2, let's bring this up a little bit. Focus 2, coordinates of our focus 2 involves subtracting 2 from the y coordinate of our center. So our center is 2, so we subtract 2, you have -4.24. Okay, so 1, 2, 3, 4.24. That goes focus 2. All right, next thing we're going to label is the length of our transverse axis. So let's go ahead and label that. We'll put that to the left. So put that transverse axis, transverse axis length. How long is it? You're going up and down 1 unit, so it's total length of 2. Now let's draw our transverse axis line. So our transverse axis line is going to be the line that contains our focus, our foci, center, and vertices. So that line right there, that's our transverse axis line. Let's change the color. So what's the equation of our transverse axis line? Let's go ahead and label what the equation is. So transverse axis line, transverse axis line is going to be x equals the x coordinate of the center, which is 2, x equals 2. All right, now let's go ahead and draw the conjugate or imaginary axis. So this right here is your conjugate or imaginary axis. All right, so let's go ahead and label it. So this is our, put it up here, conjugate axis. You can also call it imaginary. Now, what's our conjugate or imaginary axis line? The conjugate or imaginary axis line is going to be this horizontal line right here. All right, I just changed the color of our conjugate axis line to red, so let's go ahead and label that. So this is going to be our conjugate axis line. Put a label, so this right here, our conjugate axis line, conjugate axis line is going to have the equation y equals the y coordinate of our center, which is -2. Okay? All right. So the length of our conjugate axis is 2 units in both directions, so the total length is going to be 4. So conjugate axis length is 4 units long. Okay? So that's that. Now let's go ahead and write down the equation of our asymptotes. For that, we're going to be using the point slope form of the equation of a line, y minus y1 equals mx minus x1. All right, what you want to notice here, or note here, is that our x1, y1 is the center. So our center is x1, y1. All right, our x1, y1 is 2, comma, -2. All right, and our m is basically the rise over run using the direction of our central block. So rise 1, run 2. So it's going to be plus or minus 1 over 2. So when we put everything together, that basically gives us the equation of our asymptotes. Okay? So the one that's going up, that's the one with a positive slope. So let's go ahead and write down that equation. So it's going to be, this one is going to be, this is asymptote 1, asymptote 1. That's going to be y minus y1. y1 is -2, so minus minus makes it a plus, plus 2 equals m, positive slope, 1/2 x minus x1, x minus 2. Okay, so that's the equation of asymptote 1. Asymptote 2, it just has the opposite slope of this. So asymptote 2 is up here. Let's label that. This is asymptote 2. Asymptote 2. So using the same procedure, we have y minus y1, y plus 2. The same thing as this slope, as this equation, but just take the opposite of the slope. So -1/2 times x minus 2. All right, so there goes the equation of your asymptotes. Okay, let me just partition this a little bit so you don't get confused. All right, so there you have it. Now let's go ahead and write down the meaning of our result, the definition of our of a hyperbola in the context of this problem. Okay, so to do that, let's go ahead and write that down. The definition is as follows. The locus of points, whose difference of distance from two fixed points. These fixed points are the foci. Okay, from two fixed points, what are our foci again? 2, points 24 and 2 comma negative 4.24 is constantly the length of the transverse axis, okay? It's constantly 2 is the hyperbola with the equation, and they write down the original equation, negative x squared plus 4y squared plus 4x plus 16y plus 8 equals 0. All right, so that's that. All right, let's take a look at question number 4. Problem 4, we're doing the same procedure for problems 1, 2, and 3. We're going to express the given conic in standard form, identify it, find the properties, graph, label, and state the definition of the conic in the context of the problem. Okay? Now, let's consider the equation. The standard, the general form of a conic given by 2y squared plus x minus 16y plus 26 equals 0. Now this is a general form of a conic, but can you identify the conic based on the appearance of this general form? The answer is yes. If you look at this conic, what you notice is that only one variable is squared. Okay? And that is the y squared. So you have only one variable squared, that's automatically a parabola. All right? So this is a general form of a parabola. Now that we have identified what kind of conic it is and the form, we're going to go ahead and convert it into standard form, because in the standard form it's easier to find the properties to generate the graph. So in order to get this in standard form, what we're going to do is collect the variables first. Now you have to note the difference here between the approach we use for parabolas and the other conics, the general form of the other conics. In the other conics, we collect similar variables on one side of the equation and move the constant on the other side. But for parabolas, what you want to do is you want to collect the terms, the variables with the squared term on the left side, and everything else goes on the right side, okay? So I'm going to be collecting 2y squared minus 16y on one side, and everything else goes on the other side, okay? So we're going to subtract x and subtract and add, and subtract 26 from both sides. So let's indicate what we're going to do. We're going to subtract x and subtract 26 to both sides of the equation. So that's going to yield 2y squared minus 16y equals negative x minus 26. Okay? Now the goal is to create a perfect square trinomial on the left side and express that quantity as a perfect square with no coefficient in front of the parentheses. All right? So to make this into a perfect square, we have to first of all ensure that the squared variable has a coefficient of 1. This squared variable has a coefficient of 2, so we need to address that by factorization. So we're going to factor out the 2, and we'll be left with y squared minus, if you factor out 2 from 16, you have 8y. Please do not forget to divide this by 2. And then plus the term that completes the square in the y world. All right? All right, equals negative x minus 26. And then we're also going to be adding something here too. Let's figure out, we're going to figure out what that is momentarily. So let's figure out the term that completes the square here. So we have b of y. b of y is negative 8. So to complete the square, we just have to divide that by 2, negative 4, and square it, and you get what? 16. Okay, so you're going to add 16 here. Now we added 16 here. What do we add to the right side? Do we add 16? The answer is no. There's a 2 out here, so we have to add 2 times 16. Okay, so we're going to add 2 times that 16 there. 2 times 16. Okay, so we have to be careful with that too. Now we have a perfect square trinomial in this parenthesis, so we're going to factor it. You read the first and the last, and then you bring down the middle sign. And we're going to have 2 times the quantity y minus 4 square equals, here we have minus x, and then 2 times 16 is 32, minus 26 plus 32 is positive 6. All right, now what can we do next? We can factor out negative from these two quantities right here. We have 2 times y minus 4 quantity square equals negative x minus 6. Okay, and then this 1/2 has to go because in the standard form of the equation of a parabola, you don't have any coefficient in front of the squared quantity. So to accomplish that, we'll just simply multiply both sides by 1/2. So multiply by 1/2 and multiply by 1/2. Okay, so that's going to yield y minus 4 square equals negative 1/2 x minus 6. Okay, so that's the equation of our parabola in standard form. All right, now we're going to go ahead to look for the properties. Okay, so let's find the properties. First thing we're going to do is identify what kind of conic this is. We already determined that. Only one variable is squared, so we have a parabola. Okay. All right, so next thing we're going to find is the vertex of the parabola. So it's HK, so we have to be careful here. You take the coordinates of the number next to the x, -6, you do the opposite of that, which is 6, and the opposite of the number next to the y, -4, the opposite of that is 4. Okay, so there goes your parabola, the vertex of your parabola. Now, next thing we're going to find is the opening. Okay, now how do we know where the parabola opens? You want to note that the parabola always opens in the direction of the unsquared variable. Okay, the variable that's not squared here is the x variable. So we know the x direction goes side to side, which tells me that the parabola is either going to be opening to the left, negative, or to the right, positive. Okay, so since there is a minus here, that automatically tells us that the parabola opens to the left. Okay, so the opening is to the left. It's going to look something like this. Okay, now next thing we want to find is P of the focus. P of the focus. All right, to find P of the focus, we're just going to set the coefficient of the factored unsquared quantity, -1/2, equals to for P. We solve this for P, and that will give us what P of the focus is. All right. Remember the formula: A is equal to 4P, where A is the coefficient of the unsquared quantity. Now let's isolate P here. To isolate P, I can simply multiply both sides of this equation by 1/4, as opposed to dividing by 4, which would not look too nice. So multiply by 1/4 on both sides, and then we'll have P equals -1/8. Okay, so this tells me something. This negativity tells me is either going left or downwards. Since the opening is to the left, the focus always goes in the direction of the opening of the parabola. Okay, so this quantity right here is basically telling us that the focus is going to go, let's write that again, it's going to go 1/8 units to the left from the vertex. Okay, all right, now that we have P of the focus, let's determine what the directrix of our parabola. Okay, so let's go ahead and write that down. Directrix directrix. Now, how do we know where the directrix is? The directrix is going to be 1/8, positive 1/8, okay? Or 1/8 units to the right of the vertex. Now, how do I know that this is the result, or how do you determine the direction of the directrix? You simply do the opposite of what the focus is doing. Since the focus is going 1/8 units to the left, the opposite of that is 1/8 units to the right. Okay, that's how the directrix and the focus interact. Okay, the directrix is also the equation of a line. So since we're going up, since we're going side to side, the directrix is going to be going up and down. So if you have a vertical line going up and down, and the directrix is 1/8 units to the right, then you can think about what the equation is going to be. It's going to be x equals the x coordinate, which is 6 plus 1 over 4. Alright, it's much easier to generate the equation of the directrix graphically, so let's go ahead and generate the graph of our parabola, okay? The center is the vertex is 6, 4, which is located in the first quadrant. So let's go ahead and draw our axis accordingly, making quadrant 1 sufficiently large to compensate for the shifts. Now let's go ahead and graph the vertex. So we're going to go 6 units to the right, 1, 2, 3, 4, 5, 6, and 4 units up, 1, 2, 3, 4, 6, 4. There goes the center, the vertex. Now the parabola opens to the right, so this is just a sketch. A parabola looks something like this, opening to the right. Okay, now let's go ahead and label our parabola. Let's start off by labeling the vertex. This is the vertex right here, the vertex. And the coordinates of our vertex are 6, 4. I like to draw the axis of symmetry because that line contains the focus and the vertex. Okay, so that line right there that divides our parabola into two congruent curves is our axis of symmetry. Okay, so let's go ahead and label that also. So this is your axis of symmetry. Axis of symmetry. Alright, so our axis of symmetry has an equation of the form y equals the y coordinate of our vertex, which is 4. Y equals 4. Okay? Alright, I'm going to move my labels in another direction in a second. Okay, I shifted my labels to the left because they seem to be interfering with the directrix. Alright, so there goes my axis of symmetry. This line right here, y equals 4, and there goes my vertex. The next thing I want to graph is the focus. The P of the focus is 1/8 units back, so we're starting from 6 and you go back 1/8. It's going to be somewhere very, very close to 6. Okay, I'm just exaggerating it here. So there's your focus. Bring it down. And then our focus is going to be the x coordinates. You just subtract 1/8 from 6, so 5 and 7/8. And then the y coordinate stays the same at 4. So there goes your focus. Next thing we're going to graph is the directrix. So the focus goes 1/8 units to the left. The directrix is going to go 1/8 units to the right. So somewhere there, kind of exaggerating it a little bit, is much closer. So let's graph the P of the focus. Alright, and then what are the coordinates of our, what is the equation of the line of our directrix? So this is our directrix right here. So it goes through the x-axis at what value? We're going to go 1/8 units to the right. So that is a line that's constantly x equals 6 plus 1/8, which is 6 and 1/8. Okay, so let's go ahead and label that line. So this line is our directrix. And it's easy to see that it is x equals 6 plus 1/8, which is 6 and 1/8, or 49/8. Okay, so that's the equation of our directrix. Alright, so that's that. Now let's write a definition of parabola in the context of this problem. Definition: the locus of points, whose distance from a fixed point, the fixed point is the focus, fixed point 5, whole number 7 over 8, and 4, and the line is going to be the directrix, and the line x equals 6 and 1/8 is the same is the parabola with the equation, and then we can write down the original equation: 2y squared plus x minus 16y plus 26 equals 0. All right, so that's that. So thanks so much for taking the time to watch this presentation. You can feel free to subscribe to our channel for updates to other cool clips such as this. And please post a comment to let us know what you think about this presentation. More clips can be found at matcodserve.com. Thanks again for watching, and have a wonderful day.